Hi, Mr. Richards here. Today's lesson is on adding and subtracting rational expressions. Our first example has us find the sum, 4b over 15 plus 16b over 15. Well, we already have a common denominator. And if you think back, if you had something like 4 fifteenths plus 16 fifteenths, you would just add the numerators. Well, since we have common denominators here, we can still just add the numerators. So we're taking the 4b plus 16b, that's still going to be over 15. Well, 4b plus 16b is 20b over 15. And before we finish this question, we have to look, can we simplify? Well, we can look at the 20, look at the 15, and divide both of those by 5 to get 4 and 3. So our final answer is 4b over 3. In our next example, we're finding the difference. 7x plus 9 over x minus 3 minus x minus 5 over x minus 3. So once again, we do have common denominators here of x minus 3. So we're going to take our 7x plus 9 and subtract x minus 5 all over x minus 3. Now we're subtracting this entire quantity. So we probably want to deal with the additive inverse. So we'll rewrite this as 7x plus 9. We'll change this subtraction to a plus, but the opposite of everything in here. So the opposite of x is negative x, and the opposite of minus 5 is plus 5. And that's all over x minus 3. So now if I were to add my like terms up here, I have a 7x and a negative x, so that's 6x. I have a plus 9 and a plus 5, so that's plus 14. And that's all over x minus 3. This does work for an answer here. Or if you really wanted to, you could factor out a 2 and call this 2 times 3x plus 7 all over x minus 3. Either answer works. In example 3, we have an example of what's called inverse denominators. We have an 11 minus x and an x minus 11. So it's the inverse. So what we can do here, we'll rewrite our 3x over 11 minus x plus the negative 5x. And for this x minus 11, what we're going to do is multiply and pull out a negative 1. I'm going to pull out a negative 1 here. And this becomes, the opposite is negative x plus 11. And if I were to rewrite this, this is 3x over 11 minus x plus negative 5x over the negative 1. And I can rewrite this instead of negative x plus 11 as 11 minus x. Now, for my next step, we'll have 3x over 11 minus x plus this negative 1 and this negative up here can, in a way, cancel out. They turn into a positive. Remember, a negative divided by a negative is a positive. So what we're left here is 5x over 11 minus x. And since we have common denominators, we can just add these together to get 8x over 11 minus x. And that is our answer. So when you have inverse denominators, like we do here with 11 minus x and x minus 11, pull out a negative 1, take the inverse or opposites on the inside, so that then our denominators can match, and add or subtract. Next, we're going to find the least common multiple, the LCM, of each pair of polynomials. And the way in which we can do this, if we look at our 12b to the fourth, c to the 5th. If we write the prime factors here, 12 is 2 times 2 times 3. Our b, if we separate it out, is b times b times b times b to b to the 4th. And then times c times c times c times c times c for the c to the 5th. What about the 32 bc squared? Well, 32 is 2 times 2 times 2 times 2 times 2. b is times b, c squared is c times c. So if we look at the prime factors that were pulled out, we pulled out a 2, we pulled out a 3, we pulled out a b, and we pulled out a c. What we want to do is use each prime factor the greatest number of times it appears in any of the factorizations. And so we have a 2 twice here, but we have a 2 5 times there, so that would be 2 to the 5th. We have a 3 once and none, so this would be 3 to the 1st. b, we have 4 times here and only 1 time there, so that's b to the 4th. And for c, we have c to the 5th and just 2 c's here, so that would be c to the 5th. Well, if we were to take 2 to the 5th and multiply it, you would get 32 times 3 times b to the 4th times c to the 5th. And 32 times 3 is 96, b to the 4th, c to the 5th, and that is my LCM of 12, b to the 4th, c to the 5th, and 32bc squared. For our next example, x squared minus 3x minus 28 and x squared minus 8x plus 7, what we need to do is to write these polynomials in factored form. So if we take a look at our x squared minus 3x minus 28, we're looking for something that's a product of negative 28 that adds up to be negative 3. Well, that would be negative 7 and positive 4 add up to be negative 3 and multiply to be negative 28. So this is going to factor into x minus 7, x plus 4. What about the x squared minus 8x plus 7? Well, we're looking for a product of 7 that adds up to be negative 8. Well, the product of 7, negative 1, and negative 7 do add up to be negative 8. So this would be x minus 1 times x minus 7. Now, similar to the way that we found the LCMs over here by saying, all right, my 2 appeared at most 5 times, the 3 appeared at most once, the b was at most 4, and the c was at most 5, we're going to do the same thing. Our x minus 7 here appears at most 1 time. Our x plus 4 appears at most 1 time, and the x minus 1 appears at most 1 time. So we have x minus 7 times x plus 4 times x minus 1 as our LCM of that pair of polynomials. In example 5, we're going to find the sum, except now we have unlike denominators. X plus 7 over x squared minus 6x plus 9 plus x plus 3 over x minus 3. Our first step is going to be to factor the denominators. So we have our x squared minus 6x plus 9 that needs to be factored. So we're looking for a product of 9 that adds up to be negative 6, which would be negative 3 and negative 3 are negative 6. And so this is simply x minus 3 times x minus 3, which is the same thing as x minus 3 squared. And so to rewrite that now, we would have x plus 7 over x minus 3 squared plus x plus 3 over x minus 3. Next, we need to find the lowest common denominator, or LCM, of x minus 3 squared and x minus 3. Well, it's kind of nice in this example because they're both the x minus 3, and we need to see which appears the most. Well, here it appears 2 times, here it appears once. And so what we're going to need to do now The first fraction's okay. What we need to do with this x plus 3, x minus 3, is to multiply by another x minus 3 on top and bottom in order to find common denominators. So that way we end up with x plus 7 over x minus 3 squared plus x times x is x squared, x times negative 3 is negative 3x, plus 3x minus 9, all over x minus 3 squared. And so this is now going to simplify into x plus 7 over x minus 3 squared plus x squared minus 9 over x minus 3 squared, as the minus 3x plus 3x is 0x and just kind of fizzles out. Now if we look to add these, I'm going to slide this up a little bit to have some more room. We'll have x squared plus x, and then the 7 minus 9 is minus 2, all over x minus 3 squared. And we might as well look to factor this out, so we'll move up one more time here. We're looking for a product of negative 2 that adds up to be 1. Well, that would be 2 times negative 1. So x squared plus x minus 2 is going to factor into x plus 2, x minus 1, all over x minus 3 squared. And that's the final answer. X plus 2 times x minus 1 all over x minus 3 squared. For the first 15 miles, a biker travels at x miles per hour. Then, due to a downhill slope, the biker travels 2 miles at a speed that is 2 times as fast. Write an expression to represent how much time the biker is bicycling. One of the key formulas we're going to use here is time equals distance divided by rate, which is your speed. So if we first look for the time for the first 15 miles, that time is going to be equal to the distance traveled, which was 15, over the rate, which was x. And if we look for the time for the 2 miles, that time is going to equal the distance of, well, 2 over the rate, which was 2 times as fast as the first. Well, that would be 2x. So to write an expression now for the time for 15 miles plus the time for 2 miles, this would be 15 over x plus 2 over 2x. And now we want to write a simplified expression with this. And so we have a denominator of x and a denominator of 2x. So if I multiply by 2 on top and bottom here, I can get common denominators. So we would have 30 over 2x plus 2 over 2x. And adding those up, that would be 32 over 2x. And if we divide top and bottom both by 2, that's 16 and 1, which gets us our simplified expression of 16 over x. And now we can use this 16 over x to help us find part B. If the biker is bicycling at a rate of 8 miles per hour for the first 15 miles, find the total amount of time the biker is bicycling. Well, the bottom here, the x is our rate. So if we put in 16 over the 8 miles per hour, 16 over 8 simplifies to 2 hours. And so now we have one last example of finding the difference. We have 3 over x minus 5x minus 2 over 8x. Well, if we just rewrite this, 3 over x minus 5x minus 2 over 8x, we need to find common denominators. And we have x and 8x, and if we multiplied this first fraction by 8 on top and bottom, we would get 24 over 8x minus 5x minus 2 over 8x. Well, I think it's easier to add when we're dealing with this, so if we add the inverse here, we're going to end up with the negative 5x, and then 24 plus 2 is plus 26, all over 8x. And that is our answer, negative 5x plus 26 over 8x. And that's it for this lesson on adding and subtracting rational expressions. Good luck.